Okay, so we're looking at question 10 from the 2014 exam. So we're asked to write down the dual of the given LP problem, and we don't have to solve this LP problem, which is nice. Alrighty, so firstly, I'm going to write up the definition of the dual problem, given an original maximization problem, which we have here, and then we'll use that as a reference to complete this problem. Okay, so here's the definition of the dual. Where we're given a maximization problem initially, we can write the dual like so. Okay, so in our given LP problem, we are given a maximization problem here, so the first line's already in the correct form. However, our constraints that we're given all need to be in the form AX less than or equal to B. Now we have two constraints here that have greater than or equal to signs here, so we're going to have to change those by multiplying both sides by -1. Okay, so we'll rewrite those constraints out now. So we have minus x minus y minus z is less than or equal to -1. Now the second constraint, we have minus 3y plus 4z is less than or equal to -6. And the final constraint doesn't change at all, so we still have 5x minus 7z is less than or equal to 3. So now all our constraints are in the form AX less than or equal to B, where A is the constraint coefficient matrix, C is the cost coefficient matrix, and B is the column vector of resource values. Now notice that I've written all the x's in a column, all the y's in a column, and all the z's in a column, and that'll just make things easier when we write this problem out into matrix form. Okay, so writing out this LP problem in matrix form will give us the following. So we have maximize z equals 2, 4, 5, and x, y, z. And that's subject to -1, -1, -1, 0, -3, 4. Notice 0 there because there's no x present. And then 5, 0, and -7. And then we've still got the x, y, and z matrix. And that's all less than or equal to -1, -6, and 3. Alrighty, now we have this information. Let's go ahead and write out the dual, and that isn't optional. That is something you should definitely write down, given the question. Okay, so let's go ahead and do that. So the dual problem is a minimization problem, as we can see to the right here. So our new objective function is the transpose of this matrix B as our new cost coefficients for our variables U1, U2, and U3 in this case. Notice that there'll be 3 new variables as we have a 3 by 1 matrix here. Okay, so let's write out this objective function. So we have minus U1, minus 6 U2, and minus 3 U3. Okay, and that will be subject to the following constraints. Okay, and these new constraint coefficients will come from the transpose of this matrix here. And the first constraint, we look at the first column of this original matrix here. And the first constraint will be minus U1 plus 0 U2, so we leave that out. And then plus 5 U3, and that'll be greater than or equal to, given that that's the sign here. And then the number at the end here can be found by finding the first entry of this C transpose matrix, and that'll be 2. Okay, now our second constraint will be minus U1 minus 3 u2 and then plus 0 u3, so we don't write that, and again greater than or equal to the second entry of our C matrix or C transpose matrix, and that'll be 4. And finally, the last constraint again starts off with minus u1, then we have plus 4 u2 and minus 7 u3, and again that's greater than or equal to, and then the final value of our C matrix or C transpose matrix if we were to write it out in that form, and that is 5. Okay, so we've written out our constraints, and finally and importantly we have to write out that each one of the variables u1, u2 and u3 are all greater than or equal to 0, and you have to write that for full marks in this question. Okay, and as a final note, I'd like to reiterate that this step is optional, but it is helpful if you haven't done many of these questions. But of course I'd recommend to do lots of these questions and then read the information down here straight off your constraints and original maximization problem up here, as this information can be found just as quickly by looking to the original cost coefficients up here being the last numbers here, and then the cost coefficients for the dual problem being given in your rewritten constraints, and then the coefficients for your constraints can be found in the columns of your original constraints from the primal problem, as we can see here. And then making sure that you just don't forget this last line as well. And the 1's gone missing here, so I'll just quickly add that back in. Okay, and that's it for this question, and I'd recommend doing quite a few of these dual problems throughout the year and in preparation for your exam, so you can make these little shortcuts to save you some time.